In problem number 6, we need to calculate the second partial derivative of the function z, where z equals cosine of 2xy. The second derivative of this function with respect to x first, and then with respect to y, we are asked to calculate the value of this partial derivative at the point x equals to pi over 2, y equals to 1. Okay, so let's begin calculating this partial derivative by calculating the first partial derivative of z with respect to x. When we're differentiating with respect to x, the y variable is fixed. The value of the y variable is fixed, so we treat y as a constant. Now, to differentiate cosine of 2xy with respect to x, we need to use the chain rule. The derivative of cosine is negative sine. So we're going to get negative sine of 2xy. And then that has to be multiplied by the chain rule by the derivative of the function that is inside cosine. In other words, what cosine is being applied to, and that is 2xy. So we need to multiply negative sine of 2xy by the derivative of 2xy with respect to x, and that's going to be 2y. Now, we need to differentiate this derivative of z with respect to x. We need to further differentiate it with respect to y. So the second derivative of z with respect to x first, and then with respect to y second, is the derivative with respect to y of the derivative of z with respect to x which we just found. It is equal to negative 2y times sine of 2xy. Okay, so here we will have to use not only the chain rule, but also the product rule. And the reason for that is that the function that we're differentiating now is a product of two functions of y. The first factor is negative 2y, and the second factor is sine of 2xy, and they're being multiplied. Both of these terms depend on y, and so we will have to use the product rule. Take the derivative of the first factor, negative 2y. The derivative with respect to y is negative 2. We get negative 2 times sine of 2xy. And then plus negative 2y multiplied by the derivative of sine of 2xy. Now, here we need to use the chain rule, right? Because our function that we're differentiating is a composite function. It's not just sine, it's sine of 2xy. And so the outside function is sine, the inside function is 2xy. The derivative of sine is cosine. The derivative of 2xy with respect to with respect to y is 2x. And so taking all of that into consideration, we are going to get for our term here, for the second term in the second derivative of z with respect to x and y, a negative 2y times cosine of 2xy multiplied by the derivative of 2xy with respect to y, and that's going to be 2x. Let's simplify this. We have negative 2 sine of 2xy, and then minus 4xy cosine of 2xy. And that is that second partial derivative that we were asked to find. Right. Now we need to plug in our point. So plug in x equals to pi over 2 and y equals to 1, and that's going to give us the second derivative of z with respect to y and with respect to x equals -2 sine of 2 times pi over 2 times 1 minus 4 times pi over 2 times 1 times cosine of 2 times pi over 2 times 1, and sorry, and finally, so this simplifies to, of course, -2 sine of pi, and then minus 2 pi cosine of pi. Now if you remember, sine of pi equals 0 and cosine of pi equals to -1, and so our final result will be -2 times 0 minus 2 pi multiplied by -1, and the final overall answer is 2 pi.